Welcome, you guys. So the title of this panel is ASICs, Wet or Dry, and both of you have a ton of mining experience. So why don't we do some brief intros? Tell us who you are, what you've been up to, and then we'll get into it.
Sure. Mike Hamilton. I was the CTO and Chief Research Officer for Grid, acquired by CleanSpark. I've since left and am finding out what's next. Probably some 256 Foundation stuff.
Let's go!
Because once you mine a block, everybody wants on board. I was a chip designer, did some network security for a long time, and then full-time mining since 2019.
Good stuff, guys. I'm Kevin Zhang. I'm not Matt, so if you came for the Giga Talk, I'm sorry. With the new administration in office, it's like okay to be a cis white male again, so I was going to give it a shot. Jokes aside, I've been Bitcoin mining in the US for some time now. And lately I've been at Foundry the last 4.5 years. I think everyone knows who we are, especially recently mined 7 blocks in a row. I'm surprised no one commented. We actually mined 8 at one time in a row. So I guess everyone's asleep, but we'll leave that for another discussion.
Wait, hold up. When was the 8 blocks? Was that like years ago?
No, it was like 3 months ago.
No kidding.
Yeah.
Wow.
But like no one also comments that the fact that we are actually unlucky for that same 24-hour period. So we actually lost money on that day. But I digress. My background's always been in Bitcoin mining, and especially I remember back in the day when immersion mining was first coming out, everyone's very skeptical. Now people are on board with immersion mining, and now they're skeptical of hydro mining. So it's interesting to see how these technologies come about and the adoption curve and how long it actually takes. But I'm excited to be talking about this topic. It's going to be a lot of fun, guys.
Yeah, so you mentioned something interesting there. So you mentioned both hydro and immersion. So this isn't just ASICs wet versus dry as though there's one version of wet. There's actually multiple different types. So we've got immersion. Do you do anything with two-phase immersion? Because I've seen some of that recently where you're like dipping the ASIC in the solvent and it's boiling off. If you've got any experience there or with hydro, let's get right into it. Like,
sure.
Which kind of wet are we talking about here?
All right, so maybe we can take a step back and introduce all the different variants of types of mining, right? So the one I think everyone's most familiar with is air-cooled mining, and that's simply you're taking cold air and pushing it through the miner and exhausting hot air out the other side. When it comes to liquid cooling, now there's many different types. In the beginning, I think one of the more popular ones was immersion, which is what you're actually is you're taking a miner, sometimes converting an air-core miner. Sometimes it's immersion specifically designed equipment. You're dipping it and submerging it into dielectric fluid and using the fluid to kind of transmit the heat off the chips. And that's kind of, you're actually taking the fluids and you're touching that to the chips itself. Then there is Novak 3M, which is the most popular use case for two-phase immersion. Two-phase is a fancy way of saying the state of the liquid you're using to cool something is changing. So what you're doing is you're taking a fluid, you're using that to disperse the heat, and the heat dispersion happens when you're changing it from a fluid, a solid state, into a gas. So it's super cool technology, but the downside of it is, to date, it's still been very, very expensive. And the last form of cooling that's hydro is hydro. It's another form of liquid cooling. And that's where you're actually running standard water or treated water through tubes that go across the boards on the miners to dissipate the heat.
Which one of those methods, or is it all three? Do you got a mix in your operations that you use?
So we've tested all of them. The only one we don't do at scale is the two-phase, which is the Novak 3M solution.
And why is that?
It's been cost prohibitive to date, and the same has been true to immersion and hydro when it first came out. So probably it'll take some time for it to come to be more economical and more cost efficient.
So let's break this down a little bit further. So if I wanted to cool my miners with immersion, can I just take the miner and drop it in a bath of dielectric oil?
You want to?
Sure. I mean, kind of. Like most answers about anything, it depends. But really, you have to take off the fans. If you're taking an air-cooled machine, and then sometimes there's some weirdness with like the power supplies, and you might have to take the power supply fans off. Or in the case of one of my sites, we put we put popsicle sticks in there to keep the fans from spinning, so they wouldn't recycle the fluid. But there's usually some amount of work to prepare them for actual full immersion.
So it sounds like there's some labor involved and some modifications needed. Are the efficiency gains from this different type of cooling method, do they offset the extra labor that goes into setting it up?
So yes and no. I think before we kind of get into like overgeneralization of like, will this improve your economics or not? I think you have to look at the specific site that you're working with. If you can run air cool there, if it's dry, if it's cool, you may not need to overcomplicate things by going into liquid cooling or getting too fancy and cute with your infrastructure. Now, if you're in a very hot climate and heat is everywhere, there's no cold air to draw into your site, maybe that's when you start looking at these things. No different than if it's way too humid or way too wet outside. You can't use the outside air of damaged machines. That's when you look at liquid type cooling. And then to answer your question, it depends on what you paid for your miner, obviously, right? And the modifications needed. Nowadays, immersion and hydro are popular enough that the manufacturers like Bitmain, MicroBT, they're making units out of the box that are designed for those use cases. Back in the day, you had to modify air-cooled miner. You had to remove the fans. You had to jerry-rig it, like Mike was talking about it, and you also have to exploit the miner and change the firmware. So you're voiding the warranty both physically and on the software layer as well. So I think now with a lot of the new manufacturer support, it's been a lot more capital efficient and a lot more streamlined. And I think there was a gentleman here yesterday that was asking about what's miner firmware. And I think that's been like a long time meme when it comes to brains and others. There isn't much optimization for air cooling firmware for MicroBT, but where the optimization come in is on the immersion side, where your only limitation is your power supply. You can crank up the overclocking, the frequency and the voltage so much more on the chips, as long as the power supply can support it and you have good flow of your liquids to dissipate the heat.
So you bring up an interesting point. It's like kind of site specific will determine what sort of cooling method you want to apply, right? Mm-hmm. And just out of curiosity, and if you guys can speak about it, like how many sites have you all operated, and what kind of geographic locations were they in, and out of those, which cooling methods were you employing and why?
Yeah, I think I've set up several sites in various locations. So it's sort of North Texas area. We're actually doing a gas well site. We chose immersion partially because it's right next to a multi-million-dollar home neighborhood, and there's this oil well sitting behind it. And so we opted for immersion. It's a little bit hotter. It's a little bit dusty there at the well. Incidentally, we also generate on site, which is not quieter than the actual miners themselves. But that was a lot to do with the dust and the temperature. And then other sites, at Grid, we had lots of Tennessee TVA sites where it's relatively cool. Now it does get hot. It can get pretty hot during the summers. So we did lots of air cooled. We did a little bit of immersion, single phase, full immersion. Mostly from a proof of concept. Really, when you're trying to build quickly and inexpensively, air cooled, given the right environment, is generally cheaper with some other trade-offs. But so I've done a little bit of both.
Is it easier to keep the dust out of the mining equipment using immersion?
Yeah, I think that is one of the benefits, at least in the single phase, immersion, like the tank outside. The machine is basically protected. There's no moisture. There's no air. So from that perspective, it can be good for the actual machine that is not getting a lot of that exposure. But at the same time, the fluid can create other problems with plastics and hardening, and there's other issues.
How about you, Kevin? What kind of sites have you set up, and what kind of methods did you employ?
Sure. So I think my mining career, which started about 10 years ago, it predated a lot of kind of like the economics coming down of the liquid cooling. So for me, it was a lot of air-cooled sites. And if you look at it historically, similar to my sites, I was always building them where the climate was cooler and drier. But with the kind of the new innovation and the cost coming down on liquid cooling, it's allowed for new regions to break into mining. In particular, leveraging hydro or immersion. In the past, I was always mining in Montana or northern China, where there's a lot of coal power, where it's cool climates. Nowadays, you have mining in the Middle East, and they're huge fans of hydro mining over there. So we were out in Oman recently. We partnered with some of those sites that mine in our pool, over in Dubai. And also now you have South America, where sometimes it's way too humid. They're able to mine, or if they're too close to the equator, it could be too hot and too humid. They can mine because now they're using immersion down there as well. So just seeing kind of the shifts geographically, all these new locations have been unlocked. Now that the outside climate is no longer a concern, that's been pretty exciting to see.
Yeah, and I think the noise issue is also a thing too. There was lots of sites that we looked at, in many different situations where there's homes close, there's businesses close. There's in one case there was a school, literally a few hundred feet away, and just while dry coolers and the other infrastructure aren't necessarily quiet, it's a different frequency. The high-pitched fans of air-cooled mining can be distracting.
Yeah, you bring up an interesting point. So if you're running an immersion system, you don't have these fans that are just passing millions of cubic feet of air a day through the ASICs, right? And those fans are what create all the noise and are screaming, and that's what people hear. So were you making those decisions preemptively, maybe based on some of the backlash we've seen from that site that Mara runs, that they got a bunch of noise complaints? Were those preemptive decisions, or were you doing that because somebody complained to you?
We did. There was some public news around a site that we had that was that had gotten some noise complaints, and it definitely turned into a bigger thing. And so we're definitely more careful, because if you have an air-cooled site, trying to quiet an air-cooled site post-build is very difficult. Hay bales or sound walls, and then it starts to get unsightly. So designing for the sound is very important from the beginning.
Right, because you've kind of built this whole setup around these miners, right? And
Yep.
And now you're getting noise complaints and
you design the site for airflow. Well, now you have a 20-foot wall to help with the sound, but now you've restricted airflow into your containers, and it creates all sorts of other problems. And the reality was, with these big, the dry cooler manufacturers, we did some proof of concepts with one of the manufacturers. We're using 12-foot fan on the dry cooler, so it's still moving effectively the same amount of air as all the small fans, but it's a much slower rotation, lower frequency noise, and so it's much more pleasant than the Cyber Hornets.
yeah. What other environmental considerations are there? If you've got tanks full of immersion fluid, is there special considerations, secondary containment systems, dams, barriers to contain spills? Are there any considerations along those lines that go into place?
So historically there have been, but I think with the new improvements, there's two types of designs. There's a kind of an open loop system where you kind of bring water in, bring liquids in that aren't in your closed solution, and then there's closed loop, which is you're just recycling the same kind of fluids over and over again. So more and more nowadays you have closed loop systems, or you have reserves of water that you're bringing in. You're not drawing from a lake, you're not drawing from a new water source. That has led to a lot less backlash, where it's there's really no environmental concerns with that. And when we talk about kind of these environmental concerns, I always get some PTSD, because I was at Greenwich Generation, which was the very first power plant to ever mine Bitcoin in the States. And federally regulated, behind the meter. I think it was such a special project for me to be on. But then the pushback from the environmentalists were just, there's no logic and rhyme or reason. It's our fans, I could totally see the argument if we're disturbing the nearby neighbors, but they're coming in and protesting, saying we're scaring the killer whales in the Atlantic Ocean. And we're off of a lake in upstate New York, right? So I think now you're kind of taking away that side of the argument, whether it's logical or not. And I think that just makes it a much more buttoned up case when no one has any, it's more foolproof when it comes to operating without any of these environmental concerns.
That brings to mind the saying that it takes exponential more effort to refute bullshit than it does to just say the bullshit, right?
Absolutely.
So did you have to bring counter evidence to the table and say that, like, and demonstrate, no, we're not disturbing the whales?
Yeah, it's like you have all these measurements, you have decibel counters, this and that on like your kind of property lines. It doesn't matter because they'll just come up with a new excuse, right? A new complaint.
Yeah, I mean, we had some city council meetings, and you get people, of various generations, but of particular generations that are very set in their beliefs. They hear one thing. With one site we were looking at, and there was a guy that had sort of like a rescue animal zoo, and he was saying that like his animals were going to stop reproducing, and then they were all going to like drop over dead from the sound of these fans.
I've heard it all. Like, we caused the autism in their kids because the fans were too loud. I shouldn't joke about it, but those were some of the complaints we got.
You monsters.
Yeah.
Making the kids autistic and killing the animals. Jeez.
But you asked about like the containment or like fluids and environmental concerns. I mean, you do theoretically want to have the containment mechanisms if your tanks leak. I've heard of some sites where a tank springs a leak and $100,000 worth of dielectric fluid is down the drain. And so there are some of those concerns, but it's really not much different than you have to do the same thing with transformers. Transformers are filled with either mineral oil, or if you go with the fancy fluids to get a little bit of performance, you still have the same containment modes. And so it's really not anything different in the normal construction world.
What's next? Are there other cooling methods down the pike that you guys have been seeing and experimenting with, or do you think the tools that we have at our disposal now are kind of what we're going to have going forward?
So one thing I think has been emerging recently, especially with hydro mining, that's really exciting, is it's not just like cooling your miners. You're actually incentivized to capture even higher heat. So when you can actually generate a lot of heat and capture it, that's when you get your heat recapture programs. And that's, I think, one thing that differentiates hydro over both air and immersion is it's a lot easier to transfer water and capture that efficiently without much loss of the heat for whatever other use case you have for that heat itself. And I think that this is something that's been talked about a lot. Oftentimes, I think the theories and the hypotheses come out way earlier, and the technology takes a few years to catch up. Like back in the day, it was always, it's so logical and obvious. The people that should be mining Bitcoin are behind the meter. They're power generators themselves. Well, I think everyone underestimated and overlooked the fact that you have a bunch of older people wearing suits, very traditional thinking, very conservative, half the time convincing them that Bitcoin isn't for money laundering or for scams or whatever, criminal activity, whatever. So that took a long time for that adoption to happen. Same thing with the heat recapture narrative. It's no longer just a narrative anymore. With hydro mining, it's very easy to kind of capture that heat. You see it for like greenhouses. You see it for fish nurseries. So there's all these fascinating use cases. There's one other anecdotal story I'll tell. I think it's really cool. So I think everyone knows that there were really serious bans in China against Bitcoin mining 2-3 summers ago. And despite that, there are actually a few sites that still mine Bitcoin. The ones that mine Bitcoin, that integrated the heat recapture. It was hydro mining that was providing heat for nursery homes, right? So even the Chinese government can't justify shutting down the heat that was being generated for the old people in the nursery homes. So I think when you integrate in such a way that it goes hand in hand to daily life, and when it's actually beneficial beyond just kind of optimization of financials, I think that's when it's a really powerful technology.
How are they getting the heat to the nursing homes? Were they really close in proximity to the mine?
They were running the mining farms. Well, I'm going to call them these are data centers, and these are rack-designed hydro units. I think these are micro-BT M53s, or maybe one generation before that. But they were just standard rack, just like they're indistinguishable from servers, and they loop hydro.
Wow.
Yeah.
Have you found any heat reuse opportunities in the course of your operations?
Yeah, so we had talked about, there's some people trying to do, okay, don't boo me here, but it's a possible monetary option with like carbon capture is something that we've looked at. There was a few other things, like honestly, now that I'm moving on, one of the things I have thought about doing is actually doing a brewery in Austin with water that's preheated from Bitcoin mining. So instead of having to heat up cold water to boil, to brew your beer, have preheated water that you're using off the off the miners. But one of the problems that I think maybe doesn't get talked about from this heat reuse perspective is there's minimal use cases. So like the greenhouse is a perfect example. So, heating and water heating, but really where the power of waste heat is very high temperature. And that becomes a major problem because you can't run, these chips have to run in certain parameters. So you're getting water that's like, 140, 150, 160 degrees, but really you need that 200, 210 to get the temperature the temperature deltas that allow you to, either regenerate electricity, which is actually a project that I was working on, is actually taking the heat from the immersion tank and regenerating electricity to power the other things. So for like off-peak, when we're on peak, we could still keep other things up and regeneration. So there's lots of cool things, but again, the temperature of the water or of the heat or the quantity is just not quite enough to make.
Yeah, it's like just below that like industrial level heat you need. Yeah.
Yeah, and I think that's what's exciting too, because MicroBT, I think they're coming out with the model types all kind of blend in, but I think it's the M64S, which is like the higher heat version. So they intentionally generate even more heat off their models just for this use case.
Awesome. We've got just under 5 minutes left, and I want to be able to take a couple questions.
Then you can open up for 10 minutes of questions.
Okay, cool. With the last couple minutes, then let's just get some closing thoughts from you guys. I mean, I know you said you're searching for what's next. You're thinking maybe 256 Foundation, but
If you'll have me.
yeah, we'd be happy to.
100%.
But yeah, I mean, do you have any closing thoughts about what you're going to do next, or any advice for people who are getting into mining and thinking about what cooling methods they should use?
Yeah, I think I've had a few conversations the last couple of days on this. You've got your mega mines, you have the home plebs, and then I feel like there's still going to be a middle area. You've got Schnitzel doing water heaters. I think that's a thing where you can find this wasted energy to either to heat. People are using water heaters. They're going to pay to have hot water, and if you can make some Bitcoin and it costs the same. So I think there's going to be some really interesting use cases that people haven't even thought of yet in using mining to be able to take advantage of all the economics, not just the Bitcoin, but also saving in other areas and being able to reuse things. So I'm really excited to see especially with all the cool stuff with 256 and being able to open up more ability to control machines and have alternative use cases besides 100% on all the time. Trying to go as efficient as possible, like Kevin's talking about a higher heat model, all sorts of cool things that can be done, and I'm super excited to see in the coming months what people do and what comes out of that.
It's awesome. And how about you, Kevin? Do you have any closing thoughts you want to share? Or, I know Foundry just went through some structural changes in their mining operations. I don't know if you want to share anything about that or what you got going on next, or any advice you got for the audience?
Yeah, sure. So for those that didn't catch the news, we recently announced Fortitude Mining. That is the separation of our self-mining arm that was kind of all under the Foundry branch. Now it's its own independent subsidiary under DCG. So we actually have been self-mining at a pretty large scale privately for quite some time, and now that's its own business, and it's exciting to see that kind of survive on its own. It's going to be mining not just Bitcoin, but other altcoins and different things as well. I'll kind of keep that on the wraps here. But building off what Mike was saying, some closing thoughts on hydro and immersion mining. I know I talked a lot about economics and kind of lowering the cost of this and that. Don't just chase just the lowest price tag as well. I think what's fascinating about these new liquid cool technologies are they're now very, very large vendors as well as large deployments of these sites that are up and running. Recently, I was over in Corsicana visiting Riot's site, and to see the kind of different iterations that they've kind of deployed of immersion mining, you can see all the improvements that have happened over time. So I think one of the coolest things about our industry is how collaborative everyone is, and no one's going to gatekeep like if they had a good experience or bad experience with a vendor, right? Or how they deployed a certain technology. Everyone's going to be super helpful with their own experience and feedback on how they run something. If it's a brand new vendor in the space, probably not the best idea to cut like a 50, 100 megawatt contract with them before you sample them out or you get some testimonials. So it's not to throw anyone under the bus. I'm not thinking of anyone in mind. It's more of make sure you kind of reach out, get testimonials, get other people's experiences, leverage that, because oftentimes when you are going through your very first hydro or immersion deployments, it's a little bit more technical and there's a lot more points of failure, a lot more leakages, this and that. So you want to make sure that you kind of leverage as much experience and the collaborative network that's out there as you can.
Awesome. Let's get a round of applause for these guys, and then we'll open it up for some questions.